Hello viewers, and welcome back to another lecture in this MOOCs on sustainable aviation. So today we are going to talk about something which is very important and is a hot topic nowadays, and that is aircraft energy sources. So on this chart you see some of the popular energy carriers or energy sources like hydrogen, biofuel, synthetic kerosene, then batteries, liquefied natural gas, and liquid hydrogen. Yeah. And what you see is that and there are several criteria, say for example, energy density, emissions, availability, infrastructure, compatibility, and so on and so forth. And what you see is that none of the energy sources has only advantages. Every energy source has its advantage and disadvantage. And that's why sometimes it is better to combine the two. And that brings me to this slide, which is on hybrid architecture. This is a slide from NASA where they show different architectures possible for hybrid engines, where you combine a liquid energy source like kerosene or biofuel or synthetic kerosene with electric source like, for example, batteries or something else. Yeah? And just like your car, the architecture can be full electric to turbo electric or something in between like series or parallel and so on. This is a field of research where many people are working, and you will see more developments in this in the coming years. The other way of hybridizing is to combine some of the other fuels. Say, for example, on this slide is an engine that we investigated in one of our projects called as AHEAD a few years back, where we looked at combining hydrogen with biofuel. So the first, what you see here is an engine with two combustion chambers. The first combustion chamber uses hydrogen and the second combustion chamber uses biofuel. So this is another way of combining different energy sources. This is also an area where a lot of research is happening. So now that we talked about energy source, so let's talk about a couple of myth busting. So the first myth busting is, okay, why can't we fly our aircraft with only solar energy? So what happens if we cover the aircraft with solar cells and that generates enough power to fly? Would that be so? So let's take a hypothetical example where we take an aircraft, say for example, something like a twin aisle aircraft, and we cover it with solar cells, and let's calculate the amount of energy that can be generated. And what you see on this slide is that with some optimistic assumptions, it can generate around 50 kilowatts of power or so. Now that is actually less than the amount of power that is required for the in-flight entertainment system. Even the air conditioning system takes more power than this. Yeah? And please remember that the non-propulsive power requirement in an aircraft is less than 1% as compared to the propulsive power, which is in the order of tens of megawatts. Yeah? So certainly on planet Earth, it will not be possible to fly with solar cells. The other myth busting is the question, why can't we fly with nuclear energy? Well, believe it or not, but it has been tried both by United States as well as USSR or now Russia. And the idea was to have these nuclear powered aircraft, the pictures of which you see on the slide. Yeah. Now, there are several problems when you talk about nuclear propulsion. The main thing is that nuclear reactors are not so light. Moreover, they require a huge amount of shielding because nuclear radiation is very, very dangerous. The other thing is that in an unlikely event of a crash, then nuclear radiation can leak out. And certainly, we would not like to have a nuclear disaster like what has been the case with Fukushima, for example. Yeah. So, but what we can do is that we can indirectly fly an aircraft on nuclear energy. Say, for example, if we use nuclear energy to create hydrogen or synthetic kerosene, and we can use hydrogen and synthetic kerosene created by nuclear energy to fly an aircraft. And that might be something very interesting for the future, an indirect nuclear-powered aviation. Okay. Thanks a lot for watching. See you next time.